Okay, welcome back everyone. This is going to be the second video in my series where I attempt to try all the different types of logic puzzles that I can. In this video, we're going to be looking through a type of logic puzzle known as tenor grid, and I'm going to be solving actually a really tricky tenor grid. We managed to do this on live a couple of days ago now, and yeah, I've essentially just tried to solve it again, just so I can have video evidence that I actually did do, like, that I can have kind of archived footage of all the different puzzles I've done later on, because the live, I had problems with the live stream, so I can't really get a nice recording of the entire puzzle solve, and even if I did, it'd be multiple hours, so it'd be kind of a hassle to upload actually. But yeah, I mean, here you go. This is me essentially solving the puzzle again and voicing over what the sort of different ideas that I used were. I also actually I'm not going to explain the rules of the puzzle, so I'll explain them now. Essentially, how this puzzle works, there are three main rules. Essentially, each cell, so if you look in this sort of grid here, you can see at the bottom row here, 1, 3, 8, 7, 2, 6, 5, 9, 0, 4. That is a permutation of the digits 1 through 9, so every single row has to contain the digits 0 through 9 exactly once. So I couldn't have 2 zeros in one row or 2 ones in one row. Kind of Sudoku-like, except we have a 0, so there's sort of 10 cells per row. So there's essentially 10 columns. And in each row, and you can see the same is true with this row, there's a permutation of 0 through 9. Essentially, you're writing the digits 0 through 9 in some order, such that no digit is repeated. Okay, so that's the first condition. The second condition is essentially a column sum condition. So as you can see here, for example, the first column, all the digits in this first column sum to 30. And note that there are repeats. That is allowed. So you can have 2 1s in the same column. That is not Sudoku. The only Sudoku rule is the rows, okay? So with the column, as you can see, 7 plus 9 is 16, plus 1 is 17, plus 4 is 21, plus 8 is 29, plus 1 is 30, which essentially gives you the sort of sum or the clued number in blue. Okay, so the sum of all the digits in the column has to equal the sort of clued, the corresponding clued number in blue. Okay, and the same is true with 16, right? 0 plus 2 is 2, plus 8 is 10, plus 3 is 13, plus 0 is 13, plus 3 is 16, and that gives you the number in blue. So that's the next rule. And the final rule is to do with adjacency. So essentially, I can't have 2 equal digits horizontally, vertically, or diagonally adjacent. So what that means essentially is, I'm trying to see if there's a way that I can kind of show this to you. Maybe if I go back to the beginning of this puzzle, and I go, let's say down here. Let's say this digit here. Well, let's actually have a look at this digit. If this digit here was a 3, for example, let's just say this was a 3, for the sake of argument. Well, this then cannot be a 3 because, by the rule I just said, because that would mean that these two 3s are equivalent, like they're the same number and they're vertically adjacent, which is not allowed. Obviously, you also can't have a 3 here, that's just the row condition, but you also obviously can't have 3s horizontally adjacent like this, and I can't have a 3 here because that would be diagonally adjacent. Sorry, if I just get rid of these other 3s, I couldn't have a 3 here because that would be diagonally adjacent to this 3. You would have 2 equal numbers which are diagonally adjacent, right? To one another, and therefore I also can't have a 3 here, or if it was possible to have a 3 in this cell, it wouldn't be allowed, given that I know this is a 3 because that would be diagonally adjacent to this 3, okay? So essentially, once I've kind of fixed in a digit, I know where that digit can't be. So for example, like if this cell was a 3, I know there can't be any 3s in any of these cells, like sort of surrounding it, okay? So that is the final rule of the puzzle, but that's tenor grid for you, so yeah, I hope you enjoyed the video. Do try it out for yourself, it's a really tricky puzzle. But yeah, there we go. And I'm just going to I guess I can just show the puzzle here right now. This is the puzzle if you want to give it a go before the video starts. But yeah, thank you guys for watching. If you are sort of sticking through to go ahead and watch the video, thank you very much. And yeah, there we go. Alrighty, welcome back everyone. Today we're going to be solving this tenor grid puzzle. I think I have already explained the rules in a separate video, so we're going to just get straight into this. So we did this on live, and when we did it on live, we didn't do it in the same kind of methodical manner that I'm about to do it now. But ultimately, what I'm going to do sort of first is fill in every single cell with the possibility of having a digit from 0 to 9, and then we can filter out the digits that aren't allowed based on the rules of the puzzle. So, nope, that's not what I do. I'm going to go to the pencil icon, and then essentially, yeah, just put all the possibilities in every cell. I don't know if you can copy and paste, so you're just going to have to kind of watch me put all of the digits in, which is a bit weird. If you can copy and paste, it's also a bit embarrassing. I don't know how to do that, but I was like, whatever. This doesn't take too long. So there we go. There's 3 more rows. One more row. Okay, so now we can use kind of the row constraint. Obviously there's a 6 in this first row, so none of these cells here can be a 6. You can't have any repeats of digits within rows. And then we can use kind of the other row constraints here. We have 9, 4, 8, 6, 7, and 5. So we can get rid of each of those options in each cell. This cell can't be a 9, 4, 8, 6, 7, or 5 because we already have those numbers in that row. So 9, 4, 8, 6, 7, 5. 9, 4, 8, 6, 5. 9, 4, 8, 6, 7, 5. Okay, perfect. And then we can do 1803 here, 1803, 1803, 1803, 1803, 1803, 1803. And then 702 here, 702, 702, 702, 702, 702, 702, 702, and then 81, 81, 8, 1, 8, 1, 8, 1, 8, 1, 8, 1, 8, 1, and then 2, 6, 5. 2, 6, 5, 2, 6, 5, 2, 6, 5, 2, 6, 5, 2, 6, 5, 2, 6, 5, 2, 6, 5. Okay, perfect. And then we can work on the adjacency condition. So obviously there's a 9 here, so these two cells can't be a 9. There's not a possibility of a 9 here, but neither of these two cells can be a 9. A 6 here, we don't actually have any 6s adjacent to that, so that's fine. A 4 here, we have a couple of 4s over here, and a 4 up here and here, so adjacent to this 4. Okay, the 8, we have a couple of 8s up here, the 6, and I might forget a couple of things, but if I do, I'll realize them later on, so don't scream too much at me. We have some 7s here we can get rid of, and some 5s. Okay, perfect. And then we have some 1s over here, some 8s, and 0. Get rid of that 0, and then 7 over here, 7, 7, 7, 7, and 0. You can get rid of the other zeros, and then 2s, and then 8s. Okay, perfect. And then 1s over here, 1, 1, 1. Okay, and then 2s here, and then 6s here, and then 5s here. Okay, awesome, 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 awesome. So that should be everything. Sort of for the start, I guess. Start stage, the beginning stage of this puzzle. Okay, so at this point we can also lock in 0 in this row because there's essentially nowhere else a 0 can go in this row, right? Like these 3 cells can't be 0, there has to be a 0 somewhere in this row. And for the same reason, we can lock in 7 essentially here because nowhere else 7 can go in this row. So we lock 7 in there. Okay, very nice. And then we can essentially use the row condition to get rid of the zeros. Oh, actually, I already did that for us. Before it wasn't doing it automatically. I don't know what I clicked, but now the website is doing it automatically, so that's fine. Okay, and then we can kind of, now we need to start thinking about the sort of column constraints. We obviously know that the sum of the digits in this column has to be 35. So the sum of all the digits in this column is 35. But this cell here is 1, 2, or 3. So if this cell is a 0, for example, then the maximum sum we can make is when this cell is 3, and these 3 cells are 9, which comes out to be 33, which is not... no, sorry, it comes out to be 30, right? Because 9 plus 9 plus 9 is 27, plus 3 is 30, plus 0 is 30. So essentially the maximum sum we can make if this cell is 0 is 30, but we need to make 35. So it can't be 0, and equivalently for the same reasons it can't be 1, 2, 3, or 4. Okay? So that's that, and then essentially the same is true sort of for these cells here. This cell can't be 1, 3, or 4 because then the maximum sum, well, if it was 4, for example, the maximum sum would be 34, which is not large enough. And then the same is true here and also down here. Okay. And then at this point, we can also look at this column here. We need to make 22. Right now, the sum is 12. So these two cells need to sum to 10. If this is 2, there's no 8 here, so that's impossible. We could have 5 and 5 or 6 and 4, but there's no 9, 1, so that doesn't work. So this has to be 5 or 6, and then equivalently, this has to be 4 or 5. So we get that kind of off the bat. And then if we kind of look down here, we know that the sum of the digits in this column has to be 26. So essentially, if this cell here was 0, then the maximum sum we can make is 2 plus 1 plus 9 plus 9, which would be 21, which is too small. Same is true with 0 and 4; those end up not working. So this cell here has to be 7, 8, or 9. And then equivalently, if this cell's a 4, we get a problem because the maximum sum then is going to be, well, 4 plus 2 plus 1 is 7, plus 18 is 25, which doesn't end up working. So this cell has to be 5 or 9. And then this cell up here cannot be 1, 2, 3, or 4 for the same reasons, because then the maximum sum would be too small. Like if this was 4, the maximum sum becomes 25, which is too small. So 1, 2, 3, and 4 don't work there. And at this point, we can kind of also think about like what sums actually even work for this column. So we need to make 26, right? We already have 3. So these 3 digits need to sum to 23. And it turns out essentially that, well, if this is an 8 up here, then you would need these 2 digits to sum to 15. Oh, no. Yes. Yeah, you need these 2 digits to sum to 15, but that's just not possible, right? 5 plus 7 is 12, plus 8 is 13, plus 9 is 14, and then 9 plus 7 is 16. So that doesn't work. So this cell up here can't be an 8. It has to be a 5 or a 9. And essentially, if it's a 5 and this is a 5, you can't make 23 because you would need to have this being 13, so that doesn't work. So if this is a 5, this has to be a 9. And then you essentially get 5 plus 9, which is 14, plus 9, which is 23. So it'd have to be 599 or 959, which means that this cell, no matter what, is going to be a 9. It can't be a 7 or an 8. So we lock in that cell as a 9 immediately. Okay, and then now that we've kind of locked this cell in as a 9, if we look at this column here, if this cell's a 5, the maximum sum we get is, well, 18, 26, 29, 34. So this cell can't be a 5 because we need that sum to be 35. And equivalently, because this cell has to be 16, sorry, the sum of the digits in this column has to be 16, if this cell here is 4, 5, 7, or 8, then, well, it can't be 8 because then all of these cells would have to be 0, but this cell can't be 0. So it definitely can't be 8. But if it was 4, then the minimum sum that we can make out of the remaining digits would be 2 plus 3 plus 0 plus 0, which is 5 plus 4, which is 9. So we get 17, which is too large. So if this is 4, then you can't choose digits small enough to make the sum 16. And the same is true for 5, 7, and 8. So it can't be 4, 5, 7, or 8. It has to be 0, 1, 2, or 3. And then essentially the same idea is true down here. I mean, well, this cell obviously can't be a 9 because, well, we already have an 8, so we need to make 8 with the remaining cells, so it can't be 9. And down here, the same idea should be true in the sense that this cell can't be 5, 6, 7, or 9. Because if this cell was a 5, the minimum sum of the other made with the other cells would be 5 plus 3 plus 2 plus 0 plus 0, so that would be 10, which is obviously not... obviously too large, so we can't do that. Just make sure. Yeah, so this can't be 5, 6, 7, or 9, and I'm pretty sure it also can't be 4, because of the idea that, the same idea as the minimum sum, so 4 plus 0 plus 3 plus 2 would be 9, which is too large, so this cell here can't be a 4 either. These cells, if this is a 6, it can still work, because you can have 6 and 2 here, and the rest are zeros, although you wouldn't be able to have 0, 0 here. But I think we'll get into that a bit later, so it's fine. We'll leave it like that for now. And then, yeah, the same reasoning, though, goes for this. Like, if this is a 4, then the minimum sum is too large, and same with 7, so this cell can't be a 4 or a 7. And then if we look at sort of the column, this third column here, we need to make 35. If this cell's a 5, the maximum sum you can make is 29 plus 5 is 35. So these cells can't, 34, I mean. If this cell's a 5, or this cell's a 5, the maximum sum you can make is 34, so both of these cells can't be valid. They have to be 6 or 9. And obviously it has to be 6, 9, or 9, 6. It can't be 6, 6 because of the adjacency rule. Yeah, we already kind of introduced that. Yeah, and then if you look in this column here, we have 8 plus 7 is 15, plus 6 is 21. These three cells need to make 13. If this cell is 7, the remaining two cells would have to make a 6. But that's not possible because 1 and 5 doesn't work, 4 and 2, 5 and 1, 6 and 0 doesn't work, and obviously 8 and 9 wouldn't work. So this cell here can't be a 7, we can just note that straight away. And at this point, then, we're going to try and figure out whether this cell is a 9 or a 5. So if we try and assume this cell to be a 9, then this cell obviously has to be a 5. This cell here has to be a 7 or an 8. So if we look at this sort of column sum, this would have to be 6 and 9 in some order, which sum to 15. And then this would have to be 8, so 15 plus 8 would be 23, plus 3 is 26, plus 8 is 34. So the maximum column sum here would be 34, in the instance where this is 9, which means that it can't be 9 because we need to make 35. So this cell here is now guaranteed to be 5, which essentially means that this cell here is going to be 9, right? Because we need 5 plus 0 plus 9 is 14, plus 2 is 16, 17, 26. Yeah, so that column is done, essentially. Okay, and then at this point we can try and figure out the sort of try to finish the second row. If this cell here ends up being a 3, then these two cells have to be 1 and 2 respectively, but specifically in this third column, you know that these two cells have to be 6 and 9 in some order, which sum to 15. Plus 8 would be 23, plus 2 would be 25, plus 9 would be 34. So the maximum sum we can make is 34. So that cell there certainly can't be a 3, so it has to be a 2, which means these two cells have to be 1 and 3. And this cell can't be a 1 because we get the same problem with the column sum being too small, which means it has to be a 3 and this has to be a 1. And then if we try and consider, you know, which of the two options this cell is, whether it's 7 or 8. If it were 7, then if we look at the column sum, where we get 7 plus 3 is 10, and plus 0 is 10, the remaining 3 cells have to make 15. Sorry, have to make 25. These two cells make 15. This cell will have to make 10, so that's not possible, which means that this cell is now confirmed to be an 8. And then once we know this cell makes an 8, obviously these two cells will always sum to 15. So that will give us 23. And then plus 3 will be 26. So this cell has to be a 9. So that's locked in. Okay, and at this point we're going to try and figure out whether or not this cell here is a 6 or a 4. So let's try and suppose that this cell here was a 6. If this cell here is a 6 for sure, this obviously has to be a 5, there's nothing left, this is a 2 and this is a 4. Because there's a 5 here, well that gives you 15, 17, this cell would have to be a 5. And now we need to look at this column in particular, but we already have a sum of 10, so these 3 remaining cells will need to sum to 23. If this cell's a 0, you can't make 23, so this cell obviously can't be 0 in that circumstance, and it also can't be a 2, because that would give you 18. So it has to be 7 or 8. If we try and use 8 to make 23, then, well, 8 plus 9, let me think about this. You could do 8 plus 6 would be 14, but plus 7 would be 21, that would be too small. So it has to be 8, 9 something. It would have to be 8, 9, 6, right? So it can't be 8, 6, 9. It can't be 8, 4, 11, no. So it has to be 8, 9, 6, but that's not possible. 8, 6, 9, but that's also not possible. So this cell here has to be 7. And once that cell's 7, we have 17. So these two cells need to sum to 6, which can only really be done... oh, no, sorry, I mean, these two cells have sum to 15, not 6. Because we had these 3 cells summing to 23, minus 7 would be... No, 16, sorry, they have to sum to 16. That's what I'm trying to say. So 3, 7 obviously doesn't work, 4, 7 is too small, 6, 7 is also too small. I mean, the only possibility that actually works here is 9, 7. So this cell has to be a 9, but then you get these two cells both have to be a 6, and that doesn't end up working with the column sum, essentially, right? Because if this cell's a 6 and this cell was also a 6, well, then... that wouldn't work with the adjacency rule either, right? But also it wouldn't work with the column sum. You get 12 plus 18 plus 6 is 24, and plus 8 is 32. So yeah, that just doesn't work. And so you can see that this cell in red here has to be a 4, and then we can kind of use a similar idea to root out whether this cell is a 6 or a 2. So if we try and suppose this cell's a 6, this would have to be a 5. This would have to be a 2. And then what we have, 15, 17, this cell has to be a 5. And then we get the same kind of argument, right? This has to be a 7, it can't be an 8, because it's literally the same with numbers. So you get this is a 7, this is a 9, and then you get both of these being a 6, which is impossible. Okay, so we know that this cell then has to be a 2, and then we have a 5, 6 pair in these two cells over here. Okay, so now if we look at this sort of fourth column here, we know we already have a sum of 8, and we need to make 33, so the remaining cells need to sum to 25. If this is 0, that's just not possible, because you would get 9 plus 8 is 17, plus 6 is 23. Same with 1, so it has to be 3, 4, or 7, this cell down here. It can't be 0, 1. Now, let's see what happens when we try and let it equal 3, for example. If this cell here was a 3, then what do we have? We have 11, so the remaining set of cells will need to sum to 22. If this is a 4, well, 4 plus 6 plus 8 is too small. Also, 5 plus 6 plus 8 is too small. 6 plus 6 plus 8 is also too small, right? Because that's 20, we need to make 22. So this would have to be a 9, but then that forces these two cells to be a 6, which is contradicts the sort of adjacency principle. So this cell down here has to be a 4 or a 7, which is nice. Okay, and then maybe we can try and do something very similar when we have a 4 in this cell. Because again, 3, 6, 8, well, you need to make, this time you need to make 21. Yeah, 21. So 5, 6, 5 plus, well, 6 plus 6 plus 8 would be 20. So that still doesn't work. This has to be a 9 again. And this would have to be 6 and 6. So yeah, you get the same sort of contradiction. So this cell here is forced to be a 7. Okay, and so now if we kind of try and finish off this column, well, we have 15 right now, and so therefore we need to make 18 to finish it. If this is 0, we can't make 18, and similarly if it's 2, we also can't make 18 because that would give us a maximum of 17. So this top cell here has to now be a 7 or an 8. I guess we can kind of just go through the possibilities in this circumstance, although it's a bit weird. If this is a 7, this could be a 5 or 6. There are two possibilities, it's either a 5 or a 6. If it's a 6, this is a 5, then we can finish off the column like this, right? We can finish off these two columns, it would be 15 plus 2, 17 plus 5 is 22, so that finishes off that column. And then in this column, we get 21, 28. This would also have to be 5, so we get a problem because we get two adjacent 5s. So that case doesn't work. However, if this is a 5 and this is a 6, well, then what do we get? 12, 16, 18, this becomes a 4. Then we get 14, 21, 26, 27. This would become a 6, but then that means these two cells need to be a 9, which breaks the adjacency rule again. So that top cell, therefore, has to be an 8. And then we can kind of just clean up a little bit in terms of getting rid of possibilities that, or getting rid of sort of circumstances which we know don't work. So for example, here, we have, in this first column, we already have a sum of 18, we need to make a sum of 12. If this cell's a 1, these two cells need to sum to 11. It's not possible because 3, 8, 4, 7, 5, 6, 6, 5, 9, 2. So this cell here can't be a 1, which is nice. And equivalently, this cell here can't be a 3, because if it is a 3, then you need to make 9 out of these two, which is not possible. 7, 2, 4, 5, 3, 6, 0, 9, not possible. So this cell here is not going to be a 3. And then this, if we look at the second column, well, right now we have 10. This obviously can't be a 6 because that would then force these two to be a 0. So we just take away the 6 from here. That's fine. And then if we look in this column, well, we have 8. We need to make a sum of 33. Right now we have 9 plus 14, which is 23. So these two need to sum to 10. So it can either be 5, 5, or 6, 4. But it obviously can't be 3, 6, or 9 in this cell. So there we go. We get a 4, 5 pair in here, which then takes away, which essentially means that this is a 4, this is a 5, this is a 5, this is a 5, this is a 4, this is a 4, this is a 5 kind of thing. So this cell can't be a 4 because then that would force one of these two cells to be empty, which is not possible. So this can't be a 4, this can't be a 4, this can't be a 4 or 5, and this can't be a 4 or 5 because of this 4, 5 pair here, which is very nice. Yeah, and something else we can notice is that if we look in this column here, well, we have a sum of 14 right now. The remaining 3 cells need to sum to 14. If this cell's 0, then is that possible? Well, you can have... Well, no, it's not possible because that would have to be 4 and 10. This would have to be 5 and 9. This would have to be 6 and 8. This would have to be 8 and 6. So that's not possible. So this cell here can't be a 0. And equivalently, if we look in this column, we have 7 plus 4, which is 11. These 3 cells can sum to 18. If this cell's a 0, then the maximum sum you can make is 16, right? 8 plus 4 plus 4 plus 0 is 16. So this cell here can't be a 0, which means that the only place a 0 could go in is in these two cells. And the same is true with the 2. The 2 can either go in here or in here, which means that if there's 0 in here, 2 has to go in here because nowhere else it could go, and vice versa. So this cell can't be a 3, and this cell has to be a 0 or 2. So it can't be 3, 6, 7, or 9, which means... yeah, the only places a 9 can go in this row is in this cell or in this cell. And then also, and then we can essentially use this fact to disprove this specific cell being a 6. Because obviously if this cell is a 6, this cell can't be a 6. So we work under the assumption this cell's a 9. If this cell's a 9, this cell, it has to be a 6, right, via the column sum. And then this cell here would have to be a 9, because nowhere else a 9 can go. So that's a 9. And then we look at this column, where we have 9 plus 8, 17 plus 7, which is 24, plus 6, which is 30. So these two cells need to sum to 4. But therefore this cell can't be a 6, right? Because that would be greater than 4. So whether this cell's a 6 or 9, in both cases, this cell isn't a 6, right? So we know that it can't be a 6, generally speaking, so we can get rid of the 6 option there, which is a bit slick, but interesting. Useful to know. And we can also get rid, and if we look at this sort of column here, 6 plus 3 plus 5 is 14. If this cell's a 4, then the remaining two cells have to sum to 10, but that doesn't work out. There's no possibility. So this cell here can't be a 4. Okay, and at this point we're going to try and figure out the order of these two digits here. And that's kind of going to transform this puzzle from being sort of in this stage where we don't really know what to do, we have a lot of unknowns, to something where we can work a lot more with what we have. So let's suppose that this cell's a 9 and this cell's a 6. automatically this cell has to be a 9 because there's nowhere else a 9 can go. And then, under this assumption, we're going to assume that this cell's a 0. So we're going to work through a few different cases here. In fact, we're going to work through 4 different cases. If this cell is a 0, we're going to work through that case. We're also going to work through if this cell is a 1. So we're going to work through both of those possibilities. You might think there's only 2 cases, but there's actually going to be more cases that we have to consider along the way. So right now, let's assume that that's a 0. So this cell here has to be 2 or 3. But let's look at this column. Well, we have 8 plus 9 is 7. So these should be 30, right? So these two should sum to 4. You can't have 2 and 2, so it has to be 3 and 1. So this cell here has to be 4 or 7. And now we're going to do a case split. Again, we're going to say assume this is a 4, and we're going to work through the possibilities. And then we're going to say assume this is a 7, work through the possibilities. And then we're going to say assume this is a 1, and then do another case split with a different thing. Okay? So first thing says, what just happened? Okay, fine. I was like, for a second, I was really confused. It was like, these will have to be 2s, and I was like, wait, what? But okay, so yeah, we have it there as a 4. That's our assumption. And then obviously, that means that this cell has to be a 7, because there's nothing else in the row that can be a 7. Maybe let's try looking at some of the column sums. So we have 9 plus 4 is 13, plus 1 is 14, plus 8 is 22. So these two need to sum to 8. So you can do 4 and 4. You can do 5 and 3. You can't, as far as I'm aware, do 6 and 2. So yeah, this cell here can't be a 6. 4 and 4, 5 and 3, and this cell obviously can't be a 0 or a 1. This cell's a 0, so these 3 cells need to sum to 6. A couple of ways you can do that. 3, 0, 3. Not 4, 0, 2. 5, 0, 1 maybe. 4, 2, 0. Yeah, so there's a couple of ways we can't figure that out just yet. What about this column? 7 plus 6 is 13, plus 3 is 16, plus 5 is 21. These two need to sum to 7. So that's interesting. So so this cell has to be a 3, and then this cell has to be a 4. Okay, and then that locks in this cell here is 5, this cell here is 3, and then this cell here has to be 3 via the column sum, right? 11, 16, 17, 26, 30. Perfect. And then what do we have here? In this column, we have 13. We need to make these two sum to 3, so it has to be 2, then 1. And then we have a 7 here, we have a 0 here forced. And then we need to have a 4 in both of these cells. So we can't actually have a 0 in either of them, which is a problem, right? Because there's nowhere for the 0 to go in this bottom row. We can't put a 4 in both these cells because they would be adjacent, which breaks the rules. So there we go. That is our first contradiction done, essentially. So yeah, put the 1 back there. So let's go into the case then when this is a 7. Okay, so when this cell is a 7, we need to sort of look at, I guess we can look at this column here. 6 plus 3 is 9 plus 5 is 14. The remaining cells need to sum to 14. Okay, so how can that really happen? Well, if this is a 3, it definitely can't happen if this is a 3, right? Because 3 plus 8 plus 2 would be 13. So this cell has to be a 7, which means this cell here has to be a 3. And then what do we have? Well, 7 plus 4 is 11, plus 3 is 14. So the remaining cells need to sum to 15. Is that possible, though? Well, if this is 0, it's definitely not possible. So this would have to be 4. And then what do we have? They have to sum to 15. So we need to have 4 plus 6 plus 3, 4 plus 8. No, sorry, 4 plus 6 plus 5, 4 plus 5 plus 6, or 4 plus 8 plus 3. But none of those work. So there's no valid column sum for this column. Like this, you just can't complete the column in this case. So therefore we know that if this order is correct, if 9, 6 like this, then that this cell here has to be a 1. And now we can start working with those remaining 2 cases with that. Okay, so now that we have this, now that we're sort of assuming that this cell here is a 1, if we look at this column in particular, right now we have a sum of 30, these two cells need to sum to 4. This cell can't be a 2 because then this cell will have to be a 2, and that's not an option. So we can take out 2 from this cell. It has to be 0 or 3. And we're going to do our case split this time on this cell. So let's first of all assume that it's a 0. Okay, so when it's a 0, this cell has to be a 4 because that's essentially what finishes the column sum, sorry. Didn't need to do that. This cell has to be a 4. Okay. And then, well, what do we have? We can still have 5, 0, 1 here, so that's not necessarily... Oh, this cell has to be a 5, this cell has to be a 4 by the adjacency rules. There's nothing necessarily... wrong with that? Just trying to think. We need these to sum to... Oh, no, sorry. This time because there's a 1 here, we need these to sum to 5, not to sum to 6. So if these 3 cells sum to 5, well, this is a 5, you can't have 2 zeros, right? That would be a problem because they'd be adjacent, which breaks the rules. So this cell here has to be a 3. You could have 2, 0, but yeah, you can't have 0, 2 because there's no 2 here. So it has to be 3, 2, 0 like this, which forces this cell here to be a 0. And then if we look at this column where we have 5 plus 2 plus 0 is 7. So these 3 cells need to make a sum of 10. Now this cell has to be a 1. It can't be a 5, 6, or an 8. Because if it's a... well, actually, that's not... let me think about that. We need these 3 cells to sum to 10. So... let me think. Is there a possibility here that actually ends up working? Well, 2, 1, 1 doesn't work, obviously. 2, 1, 3, 2, 1, 4 doesn't work. So this cell can't be a 2. What about 3, 1, 1? Oh, wait, no, but I haven't gone through all the options. What if this is 2, 5, 1, 2, 5, 3 works? 2, 5, 3 works? Oh, no, this cell has to be a 1 because of the row. Okay, sorry, I didn't notice that. This cell has to be a 1 because of the row, right? There's nowhere else for the 1 to go in that row. So this cell is literally forced to be a 1. So then we have 8, and then these 2 cells get to sum to 9, but their max is 8, right, when these are both 4. So that's impossible. You can't finish off the column there. Okay, so that tells us then that this cell has to be a 3 if this is a 1 and this is a 9 here. So this cell's a 3, and then let's work through that sort of contradiction. Okay, so when this cell's a 3, we already know that this cell has to be a 1 because of the column sum. So that is that. We still know that these need to sum to 5. We could have 4, 0, 1 here, though. So there's not necessarily any reason why that doesn't work. 4, 0, 1, 3, 0, 2. This cell has to be... wait. 3, 5, 4, 0, 1. Oh, no, it could also be... no, it can't be 3, 0, 2, sorry. I mean 3, 2, 0 or 4, 0, 1. It can't be... this cell here can't be a 5. We know that for sure. But yeah, 3, 0... 3, 2, 0 could work, or 4, 0, 1. Okay. There's nothing wrong with that per se. Is there anything we can do with this column? Let me think. That'll be 14. We need to make the sum 14. 2, 4, 3 doesn't work. And 2, 4, 3 doesn't work. 2, 4, 7 also doesn't work. It gives you 13. So this cell has to be a 7, right? We know that for sure. So what do we have? We have 13, 16, 21. These 2 cells to sum to 7. So it has to be 4 and 3. Okay. Which means this cell here has to be a 3, sorry. And then, yeah, the only possibility left is 3, 2, 0. Okay. What about here? Well, we need to make 10. Oh, this has to be 0. This has to be 7. That's locked in now. So, yeah, these 3 cells need to sum to 10. Which is a bit tricky. 0, 5, 1 doesn't work. 0, 5, 3, 0, 5, 4. 0, 6, 4 works. What about 2, 5, 1, 2, 5, 2, 5, 3 also works. I'm trying to see whether there's anything that's completely locked in. What about in this column here? Well, we have 18 right now. We need to make 11. If this is 4, you could have 5 and 2 here. What about in this column? 9 plus 1 plus 8 is 18. We need to make 12 from the remaining cells. Well, you definitely can't make 12 if this is 0, so this cell has to be a 4. Right? But that means... okay, hold on. What have I just done? Okay, yeah. Wait, did I have that? No, this was a 7. Okay, I've messed things up here. This cell was a 7. I think that's correct. This cell we know has to be a 4. So this cell has to be a 2, and this cell has to be a 0. So these 2 cells need to sum to 10. 5, 1, 5, 3, 5, 4, 6, 1, 6, 3. So the only possibility here is 6, 4. This would have to be 3. This would have to be 1. This would have to be 5. Does this sum work? 13, 14, 19, 20. No, this doesn't work. This makes 28, right? So you get 8 plus 1 plus 1 is 10, 15, 24, 28. So that the sum just doesn't work here. 8. And also you wouldn't be able to figure out which of these two is 5 or 6, right? You just can't figure it out. Because it could be 6, 4, I think, or 5, 5, if I remember correctly. But essentially, yeah, it's just some of the column sums don't end up working out in this circumstance, which means that we've gone through every single case, right? We've tried this being a 0, this being a 1, and in both cases, we failed to find a valid solution. And that was under the assumption that this cell here was a 9. So this cell here has to therefore be a 6. This cell has to be a 9. So this is a 5. This is a 6. This cell has to be a 6 as well. And then we can finish these off. This has to be a 5 and this has to be a 4. Okay, so there we go. So that's very nice. And then what we want to do is we want to look at this cell here specifically. So I want to try and prove that this cell here has to be a 3. So what happens if we try and assume that it's a 4, for example? So if I go to this cell here and I say, okay, this is a 4. I need to try and color it in. Let's say this cell here is a 4. Is there anything that we can do with that piece of information? I'm just trying to think. Well, what do we have here? We have 14. We need to make 2, which can be done with 1, 0, 1, 0, 2, 0. Either way, this cell here can't be a 3, that's for sure. I mean, we could just try looking at columns. I'm just trying to think. So we need to make 10 with these remaining cells somehow. If this is a... Can this cell here be a 1, actually? Because if this cell can't be a 1, this cell is forced to be a 1. So can this be a 1? 8 plus 7 is 15 plus 6 is 21. If this is 22, you need to make 12 of the other ones, and it's just not possible because 7 plus 3 is 10. So this cell here can't be a 1, which forces this cell over here to be a 1. Okay, and then what happens once we have that? Well, that makes 8. These 3 cells need to sum to 9, which is going to be a bit tricky. That means this cell here has to be a 2 for sure, because if it's a 0, that would be possible. The max is 8. So 2, 3, and 4, I think. It would have to be in some order, right? Although we know now that this cell has to be a 0. So this cell has to be a 1, right? Because it's 14, 15, and this cell up here would have to be a 1 as well. Okay. So far, it seems okay. We know that a 3 has to go in here. It doesn't look like a 3 can go anywhere else. Forgot why a 3 can't go in here, though. Why can't a 3 go in here? 18, we need to make 12. I think it's just not possible to make 12 with that, right? Yeah, it's just not possible. Yeah, okay. So this has to be this cell here has to be a 3 then. And what do we have? Well, we have 14. This sum to 20. We need these two cells to sum to 9, but that's not possible, right? Because yeah, the maximum is 4 and 4, which is 8. So yeah, there we go. This cell can't be a 4, which is exactly what we wanted to show. So it has to be a 3 or a 5. And we're going to try and show that it can't be a 5. Okay, so now let's try supposing that this cell here is a 5. If this cell here is a 5, then this is 15. We have to make 1 of these remaining ones. So it can't be 1, 0, 0. It has to be 0, 0, 1. It has to be that. So 0, 0, 1. And then if we try and look at this column, we need to make 12 out of these. 3, 4, 3. 3, 4, 3 doesn't work. 3, 4, 4 doesn't work. So this cell can't be a 3. And what about 7, 4, 3? That's too large. So this cell has to be a 4. And then 4, 9 is too large, so it has to be 4, 4, 4. Okay, perfect. Then this cell here has to be an 8, this cell has to be a 3, and then these two cells are 1 and 9, respectively. And this cell here has to be a 2, because that was a 0 already over here. Okay. And then if we look at this column, well, what do we have? 6 plus 3 is 9, plus 4 is 13, 20. So these two cells need to sum to 9, but their max sum is 6, so that 5 doesn't work either. Okay, perfect. So that means that this cell here has to be a 3. So that gives us 13, so these three cells need to sum to 3. There are a couple of ways that can happen, though. 0, 2, 1, and so on and so forth. There are sort of a few options for this cell over here. what if this cell over here is sort of 5? If this cell over here is a 5, well, then this cell has to be an 8, this has to be a 4, this has to be a 9, and this has to be a 1. But then if you look at this column sum, that gives us 22. We need to make 12, which is not possible, right? Because 7 plus 3, which is 10, is the max. So this cell can't be a 5. And if we try doing it with 8 as well, let me just try and take 5 out of the options for that cell. Then if we try filling in this cell as an 8, then we get, oh, goodness me, this is annoying. That's an 8. We do 5, 4, 9, and 1. We get the same problem with the 1 here, right? We just saw that that's not possible. So that can't be an 8. And what happens then if I try and make this cell a 9? If I try and make this cell a 9, well, then this cell has to be a 1 because nothing else in this row can be a 1. So this cell's a 1, we get the same problem with the column. So that means that this cell here has to be a 1. It's forced to be a 1. At which point we can kind of maybe look at the column. So 5 plus 2 plus 1 is 8. We have to make 9 with the remaining options, right? If this is 0, it's not possible. So this cell has to be a 2, and this cell has to be a 0. And then this column has to sum to 16. We have 2 plus 8 plus 3 plus 0 is 13, so the remaining digits have to sum to 3. So you can have 0, 3, or yeah, it has to be 0, 3. So there we go, 0, 3. Okay. Let's see, what do we have here? 5 plus 2 plus 1 plus 2. That's 10. These two digits can sum to 7. So you can't have 1 and 6, so that doesn't work. 2 and 5 doesn't work. 3 and 4 works, but 4 and 3 doesn't work. So this has to be a 3, this has to be a 4, this has to be 0, and this has to be a 1. Okay, here we go. We're in the end game now. What do we have with this column over here? We have 7 plus 4 is 11, plus 6 is 17. We need to make 12 with these two, so it has to be 4 and 8. And then this cell here has to be 7. You have a 1, 2 pair here. We can finish off this column, so what's it? 16, 17, 18, 26. This cell has to be a 4. This cell has to be a 5, and this cell has to be a 9. Then we can look at these two columns. So 8 plus 9 is 17, plus 7 is 24, plus 6 is 30. The only way to make 4 here is with this as being a 3, so this has to be a 7, this has to be a 1 because it had to make 4 in the column, and this has to be a 2, and we've solved the puzzle. There we go. Oh my goodness, what a puzzle this is. It's really, really difficult, and there's so many difficult steps. I think the hardest step has to be trying to figure out this is a 6. I mean, that is really, really tricky. And it's kind of random as well when you kind of look at it in hindsight. You have to just kind of be staring at this puzzle long enough to think what happens. There's only 2 options here, and maybe try a contradiction there, but very difficult puzzle. There we go, though. We have the solution to it, and that is that. Thank you guys very much for watching. See you guys in the next one. Goodbye.